All right, so because the audio did not work on the recording, I am going to go over the work that I did in fourth period, and I'm just going to talk through it. So for first and third period, we left off at, I believe, number 9. So what we did here is we find an approximation to the nearest tenth for each expression. So for the square root of 7 plus 1, we find the approximation of the square root of 7 first. So we look at our square root chart and we see that the square root of 7 is between the square root of 4 and the square root of 9. The square root of 4 is 2 from our square root chart, and if using our square root chart, the square root of 9 is 3. So the square root of 7 is going to be in between 2 and 3. But because the square root of 7 is only 2 numbers away from 9, and the 7 is 3 away from 4, it's closer to the 3 than it is the 2. So what we need to do is we end up picking a number between 2 and 3, but because it's closer to 3, the decimal has to be between 2.5 and 3. So in fourth period, they picked 2.7. So our square root of 7 became 2.7, and then we added 1 to it to get 3.7. And because it's an approximation, what we came up with isn't necessarily going to be one of your options, but what you can do is you look at your approximate values. You see 2.5 is too low, but 3.6 is really close. That's close to 3.7. So 3.7 was going to be the answer there for square root of 7 plus 1. Then the next one is an easy one. That's the square root of 16, and that's just in your square root chart. That's just 4. So that was a quick and easy one. Then for the cubed root of 16, whenever you see the 3 on your radical, that means a cubed root rather than a square root. We look at our chart and we see that the cubed root of 16 over here fell in between the cubed root of 8 and the cubed root of 27. So the cubed root of 8 from our chart was 2, and the cubed root of 27 was 3. So we know that the cubed root of 16 has to be between 2 and 3. So we could go through and make an approximation for this. We could find whether it's closer to 8 or closer to 27 and find where our decimal is, or we could just look at the numbers that we have left over. So we already picked 2.5 and we already picked 4. So we have 3.6. Sorry, we picked 3.6, excuse me. We already picked 3.6 and we already picked 4. So, whoops, let me fix that. Let me just undo what I just did. Here we go. So we picked 3.6 for this one here, the square root of 7 plus 1. And we picked the square root of 4 for the square root of 16. So we have 2.5 and 4.9 remaining. But we found out that the cube root of 16 has to be between 2 and 3. So the only option that's left over that's between 2 and 3 is 2.5 right here. So then the cube root of 16 is 2.5. And then by process of elimination, the only remaining option is this 4.9. And you can check if you did it right by taking the square root of 24, and you can say that the square root of 24 is slightly less than the square root of 25. And the square root of 25 in our chart is just 5. So 4.9 is slightly less than 5, so it makes sense that the square root of 24 would be 4.9. Okay, number 10 says in the triangle shown, the value of b is greater than 5 or equal to 5 and less than or equal to, or is greater than or equal to 5 and less than or equal to 7. So I say 5 is less than or equal to b. That's the same thing as saying b is greater than or equal to 5. And then I say that b is less than or equal to 7. So this is our range. So I just rewrote what they wrote and what I'm highlighting right here. I rewrote this bit right here. So now what I needed to do is it says Dylan says the value of C on this triangle could be 6. And Lily says that the value could be 7. Who is correct? Explain. So what we need to do is we need to get a range for what C could be. A range is just the lowest number to the highest number that C could possibly be. So the first thing we did is we started right over here, and we said when B is 5, B is the smallest number B could be, which we wrote up here. 5 is the smallest number B could be. So then we do our Pythagorean theorem, a squared plus b squared equals c squared. And our 3 was this side right here. So that was our a squared. And we said b squared is 5 when b is 5. So that was our 5 squared. So we did 3 squared plus 5 squared equals c squared. And then using our chart, we got 3 squared is 9 and 5 squared is 25. And that's still equal to c squared. So then we did 9 plus 25 on the side here, and we got 34. And then we had that 34 equals c squared. But the issue here is we want to find c, not c squared. So to find c squared, we have to take our square root. So that's when this step came in, where we have the square root of 34 equals the square root of c squared. And I'm going to rewrite under this so you can see a little better. After I took the square root of the c squared, that just became c. So c is the square root of 34, and the square root of 34 is not in our chart, but we can approximate it. And our class in fourth period approximated it as 5.7. So the way you can do that quickly is we look in our chart, and the square root of 34 is between the square root of 25 and 36. The square root of 25 is 5, and the square root of 36 is 6. And 34 is closer to 36 than it is to 25. So we know that 34 has to be closer to 6 than 5. So we know it has to be greater than 5.5, halfway between them, and less than 6. So 5.6, 5.7, 5.8, 5.9 would have all worked, but my class chose 5.7, so that's what we picked. And then we came all the way to the right side here. We came this part next. So this was step 1, and this was step 2. So then we took the highest value b could possibly be, which is 7 from what we wrote up here. So now we did when b is 7. And we said when a squared plus b squared equals c squared, our a was still 3, so we did 3 squared, plus now our b is 7, not 5. So now we have 7 squared instead of 5 squared. So 3 squared plus 7 squared equals c squared. And then we do 3 squared is 9 using our chart, and 7 squared is 49. And then we come up over here, and we add our 9 and our 49 together. So we get 49 plus 9 equals 58. And then once again, right here, we take the square root of both sides because we want c, not c squared. So then we take the square root of c squared, gives us this c, and then we approximate the square root of 58. So over here, we found that the square root of 58 is in between the square root of 49 and the square root of 64. But it's closer to the 64 than it is to the 49. The 58 is closer to the 64. So we know that the decimal for our approximation has to be greater than 7.5, greater than halfway, and less than 8. So 7.6, 7.7, 7.8, and 7.9 would have all worked for our approximation. But our class chose 7.8, so that's what we got. So then we took, this is step 3 over here. This bit is let me do, not a highlighter. This is step 3. Okay. So now we have 5.7, which was our lowest range. That came from step 1 when we got right here. And our 7.8 came from what we just did in step 2. So now C has to be between 5.7 and 7.8. So then we go up, way back up, actually just back up here. So Dylan says the value of C could be 6. So you look in our range, that C has to be between 5.7 and 7.8. And we say that 6 is within this range. 6 is between 5.7 and 7.8. So Dylan is correct because 6 falls in our range for C. And then we look at what Lily said. So Lily said the value of C could be greater than 7. So a number greater than 7 that's still less than 7.8 that my class came up with was 7.7. That's a number greater than 7, like Lily says, that's still less than 7.8. So since it's less than 7.8, it's still within our range. So Lily is also correct because that 7.7 is greater than, this is a greater than sign, greater than 7, and 7.7 falls in our range for C. So both Dylan and Lily ended up being correct. And this, what I'm boxing right here, is what you'll end up having to put in your test. So we'll have you show, you'll do all your work, but this is what you end up typing. Okay. All right. So now the last one says scientists discovered a seahorse that has a height of about 1.24 times 10 to the negative fifth miles. Sean says miles is not an appropriate unit of measurement for the height of a seahorse. What is a more appropriate unit of measurement? Explain why you chose that unit. Find the height of the seahorse in your chosen unit. So the first thing we did is we drew this picket fence right here. Picket fences are used for unit conversions. So this picket fence right here, the first thing you do in your picket fence is in the top left, you put the number that you started with. Your 1.24 times 10 to the negative fifth miles, and it came from right up here. Then the next thing you do is you take that unit was miles here, and you copy it from the top left in the bottom. And then you have to decide what a better unit is to measure the height of a seahorse. So what my fourth period initially came up with is they wanted to put it in feet. So we found how many feet are in a mile, which is 5,280 feet. So this section here is saying that there's 5,280 feet in 1 mile. And then that's all we did for them. We ended up going to inches later, but we just went to feet at first. So for a picket fence, what you need to do is multiply your numbers straight across the top and straight across the bottom. So we have 1.24 times 10 to the negative fifth times 5,280. Now, the other thing that happens when you do this picket fence, which is why it's so nice, is that if you have a unit on top that's also on the bottom, they cancel out. So that's why there's lines through our miles here, and there's a line through our mile down here, because they canceled each other out, and we were just left with feet. So we ended up doing 1.24 down here, 1.24 times 10 to the negative fifth times 5.28 times 10 to the negative 3. So then what we did is we took the green parts, the 1.24 times 5.28, and we multiplied those together. And we ended up getting 6.5472. We just use a calculator for that because we believe there is a calculator on that question. So we ended up getting 6.5472. And then we had to deal with our yellow parts, our exponents. So for our exponents, we do negative 5 plus 3. If you're multiplying exponents together, if you're multiplying numbers with exponents together and they have the same base, so our same base in this case is a 10. They're the same base. They're both 10. We have to add our exponents. So we got negative 5 plus 3 on our exponents over here. And then we did our chart over here. So we have a positive and a negative version, a column in our chart. In our 3 right here went into the negative version, or went into the positive version because it was plus 3. And then we had a negative 5, so that went into the negative version. If they're in different columns, we subtract, which is this bit right here. Subtract. So we do 5. We take the bigger number. 5 minus 3 is 2. And then we say which column was our biggest number in. Our biggest number was 5. So that was in our negative column. So our answer has to be negative. So it's going to be negative 2. So then we got 6.5472 times 10 to the negative 2. Now we're in feet because that's the unit we converted to. So then we put our justification because it asks us up here to explain why you chose that unit. So we said that we chose feet right here. We said we chose feet because smaller units work better for smaller numbers. And then we put a little star here that inches would also be an acceptable answer because inches are still in our American units, our imperial units we call, which are like feet, miles, inches, as opposed to way up here. We'll go to another one real quick. Where was this one at? This one up here, we were dealing with kilometers and meters, which is the metric system. So you need to make sure you stay in the same system. So here, when we switched it, we switched from meters to kilometers, but way back down here, because now we're not in the metric system, we're in the imperial system, we switched from miles to feet and then to inches. So what we have so far with feet in this answer right here would be acceptable. However, we still have times 10 to the negative 2, so this is still a small decimal. It's a small number, so it's a little better, but inches would be even better. So if you wanted to get inches, you could also go back to your picket fence up here, and you could do copy your feet from the top left, go bring it down to the bottom right. Now your feet would cancel, and then when you would multiply everything across, you would have to then multiply this number down here that we got up here when we multiplied 1.24. So this number here gave us, or multiplying these two gave us this number. We would have to multiply this number then by 12 if we wanted to get inches, which we could do. It would just be more work, but it would also be a nicer answer. So that's what we did. That's explaining all the work we have. We'll also upload a PDF of the work in case you weren't here for the first part of class and you need the answers, but there won't be recording over that. You just have to look over the work. So ask a friend if you need help. And that's it. Thank you.